Dear viewers, welcome to another video in the series of data analysis. In our previous videos, I was explaining about what is called simple linear regression, and when we are plotting a simple linear regression, how well the linear regression fits the model can be understood by two parameters. One is called the R squared value, another one is the standard error. So in my previous video, I have also clearly explained how the R square value get calculated. In today's video, we will understand how the standard error get calculated. Let's get into the video. As I was explaining in the introduction, standard error of a regression equation is known as the standard error of the estimate. So we are trying to estimate the value of y with the value of x. So in this process, when we are trying to estimate, the value of y that we are estimating may not be the actual value when we are really trying to maintain the value of x. So what we call it as observed value not exactly will be similar to what we have calculated as a expected value. So this difference is what is getting represented in the metric or in a parameter called standard error of a regression equation. So what we can very simply say is standard error tells you how wrong the regression model is on an average using the actual unit on which the response parameter is getting measured. So if you are trying to measure the response parameter in terms of temperature, standard error will also be understood in the unit of temperature like Fahrenheit. Or if your response parameter is operating in the unit of centimeters for dimension, your response parameter will also, or your standard error will also operate in the unit of centimeter. So let's understand how the standard error get calculated. So for us to understand the standard error calculation, again we are taking a pair of x and y, 6 pairs of x and y, and as the 6 pairs of x and y get converted into a scatter diagram, and from that scatter diagram, if we fit a linear regression line, which is a straight line equation of y equal to mx plus c, those who are not familiar with what I am talking about, correlation or how a line get fitted, I recommend you to listen to our previous videos on the concept of correlation and equation of straight line. So once we have this equation of straight line getting created, from here on we need to understand something called standard error. Now what is standard error? So if you see in this particular example, there is an observed value of y which is 15, and there is an expected value of y which is 16.47. How do we calculate this expected value of y? We already know the equation, y equal to 1.5424x plus 4.1356. So we solve the equation with this value of x. For each pair of x and y, there is a value of x. So we solve the equation with this value of x, and thereby we got expected value of y. So here the observed value of y is 15, the expected value of y is 16.47. So the difference, if you try to measure the difference between these two, we can call it the error. For this particular pair of x and y, the observed value is 15 and the expected value is 16.47, and this distance or the difference here will be called as the error, right? But this is only for one particular pair. So now if we try to standardize this, or in other words, if we try to calculate an average of this, that is what we call it as standard error. Now how do we average this, or how do we standardize it? Very simple. We have to first calculate the individual difference between the observed value and the expected value, and this difference can be a positive value or a negative value. In this case it is a negative value, whereas in another case it can be a positive value here. And here if you see, the value could be very close to 0 because the dot is almost falling on the line. So this difference is getting individually calculated. So the difference that you see here for the first pair of x and y is 0.22, second pair of x and y is 1.47. So we first calculate the difference, and then we square these differences to take the sign out of the number, and once we square it, then we need to apply the standard error formula, and the standard error formula here is square root of summation of difference between expected value of y to the observed value of y, which is getting squared, and then divide by n minus 2. So yn minus 2 we already know in our standard deviation formula. We understood what is called Bessel's correction. So Bessel's correction is all about applying the degree of freedom to make sure that your sample is your sample is compensated for the amount of error, because sample is only a estimated value of the population. From that standpoint, we are not directly dividing with n, but instead we are dividing with n minus 1 or n minus 2. In this case, n minus 2, because we are calculating 2 degrees of freedom. It's not 1 degree of freedom, we are calculating 2 degrees of freedom. So by this, if we try to solve this equation, the first thing that we need to do is we need to calculate the summation of your expected value of y minus observed value of y to the power 2. So this value 0.55 that you see here is a square of 0.22, and 0.22 here is a difference between 7 and 7.22. So first we calculate the difference in this column, and from this we calculate the square in this column, and once we calculated the squared differences, now we are adding it up, and the summation of the squared differences is 11.76. Now if we substitute this in our formula, 11.76 divided by 6 minus 2. Why 6? Because we have 6 pairs of observation. So 6 minus 2, which is nothing but 2 degrees of freedom, and when I solve it, I get 1.71. So how do we understand this 1.71? This 1.71 is the standard error of this particular equation. So in future, if you are trying to predict the value of y by maintaining the value of x at a given level, you will get something called the predicted value. For example, if you solve this equation by replacing x with 10, then you will get a value for your y. So do you think your actual value of y will fall exactly on the computed value of this equation? No, it will have some amount of error, and that error plus or minus could be this 1.71. So this is how you need to understand the standard error. So our previous concept of r square tells you how confident you are on the equation, because that value ranges anywhere between 1, that is 0 to 1. So closer and closer to 1 means you are very confident on the equation. Closer and closer to 0, you are not confident on the equation. Whereas standard error, on the other hand, is computed on the same unit where your response parameter y is measured. So if your response parameter is measured on millimeters, your standard error should also be understood in terms of millimeter. And how it need to be, or what is the context to the standard error? If at all you are trying to solve this equation and predict the value of y, whatever value you get by solving this equation, that value is called the expected value of y. However, your observed value of y may not be exactly on your expected value of y. Your observed value of y can be plus or minus the standard error that we have computed. So that is why standard error being a bigger number, then there is less confident on the predictive model that we have, and if the standard error is a smaller number, then we have more confidence on the predictive model. So as I explained in my previous videos, your predictive model is as good as your r squared value and your standard error. So if you have a predictive model with very low r square value and a very high standard error, then that predictive model is not good enough. So for you to decide whether your predictive model is good enough or not, you need to calculate the r squared value and you need to calculate the standard error value. I hope this video was useful. In my upcoming videos, I am planning to explain how a regression equation get plotted in Microsoft Excel, and how the r square and standard errors also get calculated. So you don't have to do this hard calculations every time. So we have applications like Excel and Minitab to do this for us. So I am planning to upload 2 videos. One is on how this regression can be performed in Microsoft Excel. Another one is on how this regression can be performed in Minitab. So please subscribe to our channel to get more videos on the concepts of statistical analysis, concepts of Lean Six Sigma, tools and techniques of Minitab. I hope this video was useful. See you in another video. Thank you.